a valid split. So for this problem, we are giving an array nums, and we need to split the array nums into subarrays, and we're gonna need to check if that is valid. So what is valid? So we need to check the great common divisor. It means the GCD of the first and the last element of each subarray, which is greater than 1, and each element of the nums belongs to exactly one subarray. So what does that mean? So for example, we have this kind of nums array, and if we split it like this, 2 and 6, it is one split, and 2 and 6 is a subarray, and 3, 4, 3 is another subarray, and there's no overlap. So this is just the meaning. So the GCD of 2 and 6, it is a 2 more than 1, and the GCD of 3, 4, 3, it is a 3, which is more than 1. So this means both of them are valid. And how many subarrays? We just need to return the minimum number of subarrays in a valid subarray splitting of nums. So it means we have 2 splittings, so we're gonna return a 2. Why the second one is a valid subarray? Because we just need to check the first and the last element. We don't need to check the mid element. For example, this number 4, it doesn't matter. Yeah. So for 3, 4, and 3, we don't need to check this element 4. We only need to check this 3 and 3, because according to the description, we just need to check the first and last elements of each subarray, and the GCD of this 3 and 3 would be greater than 1, then it's going to be valid. So if we are doing some problem like this, so definitely, let me just make it clear. So for example, we have such kind of an array, 2, 6, 3, 4, 3. Yeah, because we don't need to check two neighbor arrays, we just two neighbor elements. We just need to check the first and last element. So this means we need to use some brute force to solve the problem. Actually, it's going to be dynamic programming. So the idea is that we're gonna start from index 0 for our DFS with memorization. So I'm gonna use the DFS with memorization to solve the problem. So we're gonna start from the first element, and we're gonna check one by one. So for example, 2 and 2, it's going to be a valid one, because 2 with itself, GCD of 2 and 2, it is 1. It is also valid if we split it, but it is not the maximum split, right? Yeah. Or we can split it from here, 2 and 6. 2 and 6 is also valid, right? Because the GCD of 2 and 6 is 2. So what about 2, 6, and 3? It is not valid. Yeah. What about 2, 6, 3, and 4? It is valid, because 2 and 4 is valid. But what left behind is 3. 3 and 3 is valid, so this is also a valid splitting, and the result is also 2. I mean, from 2, 6, 3, 4, 3, this is a valid splitting. But from 2, 6, 3, 4, and what left behind for that 3, this is also a valid splitting, and it is 2. But we're going to return the minimum splittings, so it's going to be 2. Yeah. So this is the basic idea. So the dynamic programming idea is we just make the problem smaller and smaller. Yeah. So let's just restart. If we split from 2 and 6, so this means this one is finished. So what left behind is 3, 4, and 3. Yeah, this is one splitting. For 3, 4, and 3, because this 3 and this 3, where the GCD of this 3 and this 3 is going to be more than 1, because it is 3, which is more than 1. So this is also valid. So 1 plus 1 is going to be 2, and this is going to be the minimum number of splittings. Yeah. Now let's just use this kind of idea to solve the problem. So we're going to prepare the length of the array, and we're going to use a case, and we're going to define a function of DFS, and we're going to start from the index I. So I going to be starting from 0. So if I equal to n, this means we've already used up of the array. It goes out of the boundary, so we're going to need to return a 0. Otherwise, we're going to prepare the minimum number of splittings. So we're going to prepare it as infinity, and then we're going to split it one by one. So for I in range n, let me think about it. So for j, yeah, we're going to use another index j to split it. So for j in range from I to n, so we're going to split it from all those places. Yeah, so basically it means we're going to split it from here, this 2 and 6, 2, 6, and 3, 2, 6, and 4, 2, 6, 3, 4, and 3. We're going to split all those possible areas. So we need to have a tag if GCD with nums I and nums j if it is more than 1, so definitely this is a valid splitting. So we're gonna choose the minimum instead of a maximum. The result with what? Yeah, of course we're gonna make it smaller. We're gonna make this problem smaller. So it's gonna be DFS with j plus 1 and plus 1. Yeah, so this means if so for example, I gonna be starting from 0 and this g gonna be from 0 or maybe g equals to 1, so it means 2 and 6. So it's gonna be the next, it's gonna be starting from this g equals to 2, so g plus 1 gonna be 2. Yeah, so the idea is that we just split the problem, make it smaller and smaller until we find the answer. So finally, we're gonna return a result. So the result is gonna be DFS with 0. Now we need to return result if result not equal to infinity. So if it's let me just change it, not equal to infinity, else we're gonna return a negative 1 according to the description. Yeah, as you can see it works. Now let me just submit it to prove that it can pass. As you can see, it passed for all testing cases, and I think this idea is really easy to understand, and normally it should be okay for an interview. Otherwise, you have to use a tabulation. It's going to be much harder because it's going to be a real programming. But for this one, I still think it is okay because this is a DFS plus memorization to solve the problem, and it's going to be really easy to understand. Yeah, and the time complexity. Let's just check that. So here we have a DFS. This is a DFS. How many I? It's going to be the length of the nums array. Let me think about it. So I going to be length of the array 1000. So here we have another for loop. This is another 1000. So the time complexity going to be n squared. N going to be the length of the array. I think that's all about it. Thanks for watching. See you next time.